The half-life of radioactive actinium is 21.77 years. What percent of a present amount of radioactive actinium will remain after 19 years? So half-life is telling us the time it takes for half of the substance to decay. So that means that this substance is following the rule of exponential decay. Y equals A times e to the bx. So we know at time equals 0, there's going to be 100% of that substance. So if I plug that in, 100 equals A times e to the 0, we know that e to the 0 is 1, so A is 100. And you actually didn't even need to show that work if we know that the initial amount is 100. So now we know y equals 100 e to the bx. The next thing they tell us is the half-life is 21.77 years. So that means that y of 21.77 is going to be half of the substance, which is going to be 50% of the substance. So plugging into this formula, 50 equals 100 e to the 21.77 b. Now I can use this to solve for b. Dividing by a 100, I get 1/2 equals e to the 21.77 b. Now I can use inverse properties. ln of 1/2 equals ln e to the 21.77 b. Remember, ln e is inverse as it's going to cancel out. ln of 1/2 equals 21.77 b. So b equals ln of 1/2 divided by 21.77. And if we check that in our calculator, we'll see this is less than 0, which does prove to be decay. So now we know our formula is y equals 100 e to the ln of 1/2 over 21.77 x. And notice, I'm not going to plug anything into my calculator just yet until the final step. So they want us to find the amount that will remain after 19 years. So y of 19 is 100 e to the ln of 1/2 over 21.77 times 19. Now this I'm going to plug into my calculator. Y of 19 is approximately 54.610. And remember, this is all percentages. So we can say 54.610% of actinium. Did I spell that right? Actinium. Yep. After 19 years. So we can create these models using information given.